Hey everyone, and welcome. Today, we're going to dive into one of the most basic shapes you see everywhere, the triangle. Now, it might look simple, but it turns out there's a whole secret world, a really organized system hidden within its three sides. So, let's get into it. All right, to kick things off, let me ask you a quick question. What does a yield sign have in common with a perfect slice of pizza? Yep, that's it. They're both triangles. And today, we're basically going to explore their entire family tree. Think of this as your field guide to identifying every single one you'll ever meet out in the wild. So, where do we even start with sorting all these out? Well, it turns out there are two main ways. Think of them like blueprints. The first one, it's all about the length of their sides. So let's put on our imaginary construction hats and focus just on that. First up, we've got the scalene triangle. You can kind of think of this one as the non-conformist of the triangle world. The rule here is super simple. None of its three sides are the same length at all. So yeah, the big thing to remember for a scalene triangle is just this. 0 equal sides. Every side is its own unique length. Simple as that. Okay, so let's switch up our blueprint a little. What happens if we decide to make two of the sides exactly the same length? Well, that gives us our next type, the isosceles triangle. And this is where it gets really interesting. See, when you force two sides to be equal, something kind of magical happens. The two angles at the bottom of those sides, they become equal too. It creates this perfect balance, which gives the triangle a line of symmetry right down the middle. All right, so we've done triangles with no equal sides and triangles with two equal sides. You can probably see where this is going, right? What if all three sides are equal? That's when we get the most perfect, most symmetrical one of them all, the equilateral triangle. And with this perfect side-to-side balance comes a magic number for its angles. Every single corner in an equilateral triangle is exactly this, 60 degrees. So that's the key takeaway here. 3 equal sides always means 3 equal angles. And since we know that all the angles in any triangle have to add up to 180 degrees, well, you divide 180 by 3, and what do you get? 60 degrees for each one. It's just perfectly balanced. Okay, let's do a quick check-in. This little table sums it up perfectly. We've got scalene with 0 equal sides, isosceles with 2, and equilateral with 3. See the pattern? 0, 2, 3. Makes sense, right? Awesome. All right, let's put that first blueprint away for a second and pick up a totally new one. This time, we're not going to look at the sides at all. Nope. We're only going to classify triangles by looking at the angles inside them. First one in this group is the acute triangle. The rule here is dead simple. All 3 of its angles have to be acute, which is just a fancy way of saying they're all less than 90 degrees. So you can just think of them as having 3 sharp corners. And yeah, it's an all or nothing kind of deal. Not 1, not 2, but all 3 angles have to be under 90 degrees for it to be called an acute triangle. Okay, next up is probably the most famous triangle on the block, the right triangle. Its entire claim to fame is based on having one, and only one, perfect boxy corner. And that perfect corner is, you guessed it, exactly 90 degrees. I mean, this angle is the cornerstone of, almost everything in geometry and construction. It's the angle of a perfect square corner. So a right triangle is defined by that single 90-degree angle. And this gives the side directly opposite that angle a special name. It's called the hypotenuse. You are going to hear that word a lot in math, so it's a good one to remember. So what if one angle opens up even wider than that perfect 90-degree corner? Well, that's when we get the obtuse triangle. It's defined by having just one angle that's greater than 90 degrees. Now, what's interesting is that the other 2 angles in an obtuse triangle are always going to be acute. They have to be. But that doesn't really matter. It's that one big, wide-open angle that gives the whole triangle its name. As soon as one angle tips over 90 degrees, boom, it's officially an obtuse triangle. Okay, so we've got our names based on sides and our names based on angles. But here's the big reveal, the moment where it all comes together. These 2 systems, they aren't separate, they actually work together. This is where it's all going to click into place. I want you to think of it like this. Every single triangle in the world has a first name and a last name. Its first name comes from its sides, scalene, isosceles, or equilateral. And its last name comes from its angles, acute, right, or obtuse. So you can totally have something like a right isosceles triangle or an obtuse scalene triangle. They combine. And really, that's the whole system. So before we wrap this up, let's just quickly nail down the most important takeaways from all this. Okay, the number one thing to remember is that we classify triangles in two ways at once, by their sides and by their angles. This means every triangle gets a name from both of those systems. And really getting this down is so important because it's basically the foundation for a ton of other stuff in geometry. So, there you have it. You can now look at pretty much any triangle and know exactly what to call it. But the real question is, what's next? Now that you can identify them, what kind of powerful secrets do they unlock? I'm talking about things like the famous Pythagorean Theorem that only works for right triangles. That's where the real adventure in math and geometry truly begins.